Hi, and welcome to Failurology, a podcast about engineering failures. I'm your host, Nicole.
And I'm Brian, and we're both from Calgary, Alberta, Canada.
Thank you again to our Patreon subscribers. As always, we really appreciate your support and help in making this show come together.
For less than the cost of a cup of coffee, you can hear us talk about more interesting engineering failures.
Our mini failures come out on opposite Sundays from our regular episodes, and they often cover older or less known failures that have occurred that don't quite fit the format for our regular episode, but we still think are really interesting, and we want to share those stories with you. So please come over to our Patreon and support our show. We'd love to see you over there.
This week in engineering news, fluid-based light filtering technology, which I did not know was a thing at all. Researchers at the University of Toronto developed a multi-layered fluid window system that aims to drive sustainability in the building industry. The fluid that flows through the windows is used to control the type and distribution of solar energy that enters a building, which sounds super cool. It is even able to filter out infrared heat while allowing light to pass through. So this is often a really tricky balance from what I understand, because light coming in means less overhead lighting and happier people inside, but it also means a lot more heat. So in the winter months, heat is okay, but not in the summer. The condo I live in has giant windows. In the winter, it's often really cold. In the summer, it's often very warm. I have air conditioning. It's great. Overall, big windows are great for visibility, not great for heating or cooling control.
And you're northwest facing too, so you don't even have that much of a sun load. Imagine if you were south facing.
Yeah, so my office and kitchen in the condo, they kind of face north. Bedroom and the living room have like a west facing stack of windows. So the temperature regulation's a little tricky. I'm like I said, I'm pretty thankful I have air conditioning. The heater leaves a little bit to be desired, but I still really like my condo.
Not to say that other areas don't have high solar loads, because of course that's the case, but Calgary has surprisingly high solar loads, at least compared to what you'd think it would be, and it often gets underestimated. I mention this because the fluid-based light filtering window system is designed to help counteract that. But also I was fortunate enough to see a bunch of capstone projects that were completed by SAIT students, which is our Calgary Polytechnic School, as well as one from the University of Calgary. And one of the groups said that they underestimated the solar load in Calgary, and I laughed and told them that's a rite of passage as a mechanical engineer in this city, because everyone has a moment where they say, "Oh, I didn't know it was going to be that much," because it's quite a bit. I think we rival some southern states as far as our solar load. We have 300 and something days of sun per year. We don't get a lot of rainy days. And so, I mean, our heating loads are obviously higher. It does get very cold here, but our cooling loads are higher than you'd expect them to be, or at least the peak cooling load. So when you're sizing your equipment, your cooling system needs to be quite a bit larger than you'd think it would need to be for a city that doesn't really have a super hot summer.
So current systems in buildings, they either let both light and heat in, or they block them both, but they aren't able to block one while the other passes through. So this is a significant change to the current window systems, I guess, that are in buildings. And so the savings, they're said to be quite significant, with minimal energy required to pump the fluid through the glass, which is a great feature to have. So if you want to read more about the fluid window system, check out the link on the webpage for this episode at failurology.ca.
Tired of washing dishes?
Dishwasher broken?
Flip the dishes over. There's a second side to those.
At least the plates.
We can't help you out with the bowls, but if it's the morning and you have no bowls, you're already in a bad spot if you wanted cereal.
Use a mug or something. You're probably still half asleep anyway. Who's gonna judge you for eating cereal out of a mug?
We got your back. Flip the dishes.
Now on to this week's engineering failure, the Surfside Condo Collapse.
So this one's kind of important for us in a weird way. When this collapse happened, that was right when Brian joined the show. And so the first two news articles that we did were related to this collapse. This was also a really significant failure that shed light on a lot of issues that plague, I think, throughout North America and probably other parts of the world about building maintenance and making sure that condo groups and other owners groups have the tools that they need to make sure that their buildings can stand the test of time, literally stand up over time. So this one's special to us, and I'm really drawn to this story. I'm sure part of it is because it's so well known and it was so tragic, but I also just find this to be really interesting. There's so many parts and pieces to this story. It's not just about a structural collapse. There's envelope issues, and there's the people factor of being told they have a problem and not really understanding how bad it was. And we're going to get into all of that, but there's a lot of factors that go into why this building collapsed as catastrophically as it did, and I find that really interesting.
Yeah, so like Nicole mentioned, we did cover this. I think it was part of two engineering news pieces on early episodes that we did a couple of years ago. So some of this we've touched on before. Now there's kind of more of a report out. There's additional details. So we figured we'd do this as a full episode of Failurology, even though we've talked about bits and pieces of it way back when this was happening. So Champlain Towers South was a 12-story beachfront condo in Surfside, Florida. And Surfside is roughly 17 kilometers northeast of downtown Miami and located on a series of islands between Biscayne Bay and the Atlantic Ocean. Champlain Tower South partially collapsed at 1:22 a.m. on June 24th, 2021, causing the death of 98 people. And the 2-year anniversary is 6 days after this episode comes out, which is another reason why we wanted to cover it at the time that we did. 4 people were rescued from the collapsed section, although one died shortly after. 35 people were rescued from the uncollapsed portion of the towers. 12 days later, it was confirmed that there were 136 survivors. The building itself was demolished 10 days after the collapse. So I just want to talk a little bit about the initial building construction, some things that were going on in terms of bylaws and regulations within Surfside, and then some other areas in Florida before we get too far into the collapse and some reasons for it collapsing. The South Building was built in 1981 as part of a 3-building complex, Champlain Towers North, completed in 1982, and Champlain Towers East, built between the two and completed in 1994. So these buildings are built over a period of 13 years. The South Building and the North Building, those were, completed, in 81, 82, so kind of right with each other. The East Tower later on in terms of the building lifespan. So
The other thing that's weird to me, at least, not living in a place that has as much water as Miami does, and I'm not a structural engineer or a geotechnical engineer, but these islands don't look like there's much to them. And so I'm surprised that they have the structural integrity to have towers of this size on them. And maybe I'm just misunderstanding their size from Google Maps, but these islands are 5 or 6 blocks wide. They're not very big. And so to put a series of towers on them just seems a little bit suspect to me. That's not even necessarily why this building collapsed. It just seems odd.
yeah, on such a small island or such a small footprint, there's a lot of load from concrete structures and rebar structures and 12 floors in this case of building material and people and live load. So yeah, there is quite a bit of weight, a lot of mass on these islands. And yeah, all 3 buildings in the Champlain Towers complex were an L shape. As I mentioned before, they were all 12 stories tall. And the South Building contained the most units with 136 units. The penthouse portion of the buildings was controversial since an exemption was needed to exceed the building height limits in Surfside. The penthouses were also not on the original building permits. When the penthouses were added at the last minute, it led to a cease and desist order while the town debated the extra level, which makes a lot of sense to me. In addition, the first general contractor quit and a second one was replaced. So there's some turnover happening here on the general contractor side. There's some late additions to building plans. This is going in front of town city council to make a decision. So there's a lot of administrative and external factors that are already working against this building project.
And we don't necessarily know the circumstances surrounding this, but it's completely possible that they knew the penthouse was going to be added later, deliberately excluded it from the building permit, waited till they were already under construction and said, but we're already under construction and we need these penthouses to make this a viable project, and kind of pigeonholed the city into saying yes. That is entirely possible. I don't know if that's the case, but it is possible. I think it's also a really big red flag when your general contractor quits and your second one was fired. again, that happens on projects. People get fired. There's clashes, personality clashes, issues happen. That happens, and it doesn't necessarily mean it's a bad project, but it always makes me ask questions about why did they quit? Why were they fired? It normally costs more to replace your general contractor than it does to find a way to make it work. So I'm just curious what exactly was going on that led to this. And we're going to get into it in a bit, but there was some other shady things that were going on that make me wonder if the first general contractor who quit said, that's not okay, I'm not doing that, and walked away from the project, because sometimes that's what you have to do. If someone's trying to get you to do something that you disagree with or that you think is not safe, you have to walk away.
Yeah, and also as engineers, Nicole and I both being engineers, that's also part of your professional obligation, just recognizing that sometimes you just have to walk away from a project. The city of Surfside had a moratorium on new development in the 1970s due to water and sewer infrastructure limitations, and Champlain Towers was the first new construction allowed after that was lifted. The developers of the complex paid the city $200,000, which is $831,000 in today's money, to help replace the sewer system and get approval to build the condos.
And likely what that meant was that the existing water and sewer systems were undersized for buildings that were 12 stories tall. And so they likely had to upgrade the size of the service or the pipes buried in the street to allow more buildings to be connected to them at that time and in the future. So that is quite a bit of work to dig up the street, replace the pipes. Potentially the water treatment plants downstream needed some upgrades to handle the extra flow. So that is very common. That happens. I think there's probably parts of every city that are old and haven't been upgraded for a while, and they're dealing with infrastructure that was there when it was all, single family houses or smaller apartments. And then someone comes in and wants to build a really large apartment, and those services have to be upgraded to accommodate that. So that's not uncommon.
Yes, so where I live, so I live in an area of Calgary that used to be, very low grade industrial, kind of 2 and 3 story warehouses. Now it is slated all for high rise condos. So every now and then when a new building is being built, I see them tearing up the street. They're doing work with the water mains or, resizing gas mains and stuff. So yeah, like Nicole said, it's not an uncommon thing to do as development just changes, what used to be there. So this seems like a fairly common thing. I don't think there's any issue with this. The developers paying, the city to upgrade the sewer systems. They needed it for their condos. It was part of the approval process. It's just a cost of doing business for their condos. So in addition, though, to the 12 stories of condo towers, the buildings also contained underground parking and an outdoor pool at the ground level. So due to the L-shaped building with a rectangular parkade, the base of the pool made up the roof of the parking garage below.
So there's a few different ways to construct a building. Usually the structure is some combination of metal and concrete. And the best I can tell from all the reading I've done on Champlain is that the building was constructed using reinforced concrete. After the formwork is installed, which is the mold that the concrete is poured into, rebar or metal rods are placed in a grid-like pattern on the formwork to reinforce the concrete. And the diameter of the rods, the spacing, the height within the slab, and a few other items impact the strength the rebar gives to that slab. And in some cases, there may be 2 or more layers of rebar, and there's usually something that resembles a cage of rebar around the tops and bottoms of the columns to provide that extra strength. And then after all of that rebar is in place, the concrete gets poured into the mold, sets, the mold comes away, and goes above that to pour the next floor. So formwork, usually, we call them tables. They move from floor to floor as the building is built. And that's why it's usually a lot more cost effective to build typical floors, because then your formwork doesn't need to change as you build those floors. And usually coming out of the ground is a lot of work because it's all kind of one-off details. And usually the main floor and the podium, which is probably the first 2 or 3 levels of a building, are a lot of work. But once you get into that typical floor, because your forms are just repeated and you kind of get into a rhythm. So in my experience, once a condo building gets into the typical floors, they're pouring about a floor a week. So they really do get moving once they get to that stage. Now, most of my rebar knowledge comes from years of trying to put holes in slabs for pipes and ducts while avoiding rebar, which is a game of Tetris in itself. And in new construction, you can either locate the holes away from the rebar, or sometimes extra rebar can be added around where you need the holes to be. Of course, you need the structural engineer to be on board with that, and they have to approve that. But depending on what you're trying to do, if you have a large duct that needs to go from the roof of a building all the way to the main floor, you have to build a hole or a shaft to put that duct in, so you need to make allowances within the slab. In older buildings where you're cutting holes to put in new pipes, if you're doing some type of retrofit project, the hole has to go where the hole has to go, like under a toilet, for example. Oftentimes, reinforcement has to be added around that opening to transfer the load around the hole. Structural engineers work their magic. They come look at the site and the size of the hole that you want to put, and they tell you how much reinforcing you need.
The collapse of Champagne Towers started at 1:14 a.m. with a partial collapse of the building. So from video footage, this appears to have taken place in the parkade. Then at 1:22 a.m., so 8 minutes later, the middle section of the building collapsed, followed by the eastern wing of the building. The collapse took 12 seconds and was caught on security cameras nearby. 12 seconds to me seems like a really quick time frame to go from having a building to not having a building.
Yes, especially too because it's 1 in the morning, so there's a lot of people that are home. You hear this big rumble. You look out your window, part of the building is collapsing. If you're in the eastern wing that collapsed second, you don't know if it's going to collapse or not. You don't know that that's coming, so you don't have time to escape. So you're just probably frozen there. And then if you're in the part of the building that didn't collapse, again, you don't know that at the time. Like looking back, we know which parts collapsed and which didn't. But in the moment, you had no idea. It would be sheer panic. It would be so terrifying. I have watched this collapse video so many times. Not necessarily intentionally, it's just on a loop. And so I keep watching it to see if I see different things, as it keeps playing over and over again. But this would be such a terrifying experience for everybody inside the building. I can't imagine what that would have been like.
This type of collapse is referred to as a progressive collapse because it started with the failure of a primary structural element, which then led to the failure of adjoining elements.
Okay, so we're going to get into the possible causes of this collapse. And there has been a lot of reports. There's been a lot of speculation. There's been a lot of people looking into this. This was a pretty well-known collapse. And so we're going to share a lot of those different thoughts and theories on what happened as we kind of work through the backstory of how we got to this collapsed moment. So an engineering report was completed in 2018 that notes the waterproofing layer around the pool deck was not sloped. So remember the pool was, the parkade was a rectangle and the pool was on top of that. The base of the pool makes up the ceiling of the parkade in that corner of the building. There would be a structural slab that would make up that main floor of the building and of outside that the pool would be supported by. And then on top of that goes a waterproofing membrane and then pavers or decorative tile or whatever the topping layer would be. But since the pool deck, the structural layer was not sloped, or even the waterproofing layer was not sloped, when water landed on that, it wasn't able to drain away. And it also likely was underneath whatever the topping layer was, so it also didn't evaporate. And in an area as humid as Miami, it could take a very long time to get rid of that water. And so since it couldn't evaporate, over time, it caused a lot of damage to the pool deck. And so what will typically happen is any cracks that occur within that slab, the water will start to corrode the rebar inside of that concrete. And over time, it will slowly erode that rebar and the concrete. The cracks will become larger, and it just slowly creates these almost invisible damage inside the slab that's very, very detrimental, as we can see with this collapse. Now, some of these cracks, by the time the collapse actually occurred, were quite sizable on the ceiling of the parking deck underneath the pool. And so this 2018 report went as far to say that the pool deck was beyond its useful life and required replacement. It also noted that, quote, failure to replace waterproofing in the near future will cause the extent of the concrete deterioration to expand exponentially, and the repair could be, quote, extremely expensive, which essentially means that it's getting worse and worse, and the worse that it gets, the faster it deteriorates, and it's getting to the point that it's starting to become really dangerous and it needs to be fixed right away. And the longer you wait to fix it, the more it's going to cost. And so the estimates for the repair in 2018 were about $9 million. which is not what it ended up costing when they got around to trying to fix it. In October 2020, engineers noted that repairs around the pool couldn't be completed without destabilizing the area, so they had to come up with a new plan. In April of 2021, a letter was sent to residents with a $15 million repair program. So they were quoted 9. By the time they got around to it 3 years later, it was actually going to be $15 million. I mean, maybe that's the budget price was a little bit light, but it's likely that the concrete had just deteriorated so much more that the repairs were much more extensive than they thought they were going to be. The roof was also part of the repair program, and this work was underway at the time of the collapse, but the pool deck had not started. And I understand it's really, really complicated. It's really, really expensive, and you can't see the damage. So you think, oh, it can wait. We'll push that off. But I think this is a really good lesson in why that's not a good idea. In addition to rain and pool water getting into the cracks due to the location near the ocean, it was highly likely that salt water had also infiltrated the cracks, which can cause more aggressive spalling. And spalling is when large fragments of concrete break off of the larger mass. After the collapse, photos came out from a pool contractor that showed standing water, cracking concrete, and corroded rebar next to the pool. And the photos were said to have been taken 38 hours before the collapse. A bystander also took a video of water pouring into the parking garage from above and large fragments of concrete lying on the floor. And the video is stamped 7 minutes before the collapse. When Brian mentioned that the collapse started at 1:14 and then the middle section collapsed at 1:22, so around 1:14 is when that video was taken of the water underneath the pool. Okay, so in addition to those issues, a report found that the building has less rebar than the construction drawings had shown in the footings and columns. And the report notes that this alone would not necessarily cause the collapse. It's possible the rebar was reduced during construction, and it's possible that the design showed more rebar than required, but it's also possible that the contractor cut corners and the engineer didn't notice, which is really unfortunate. I don't know enough about structural design to say definitively that if they cut corners and it really was that bad, the building wouldn't have stood for 40 years, because that's not necessarily the case. But it is somewhat surprising that it would stand for 40 years without really too much issue and then all of a sudden catastrophically collapse because the rebar was a bit light. That doesn't seem like it would be the primary cause of collapse, but it's possible it was a contributing factor. The columns that held up the surviving portion of the tower were almost double those of the sections that collapsed, violating building code requirements at the time. So they didn't even meet the code requirements back in the late 70s when this building was built, which is unfortunate that the engineer wasn't following the code requirements and that the city officials didn't notice. And I wonder if that's one of the reasons that the general contractor walked off the site, because they flagged this as an issue and the developer was unwilling to correct it. And I don't know that for sure. I'm speculating, but that's entirely possible. The columns around the pool deck were the smallest, which is surprising because the pool is very, very heavy. Water is very, very heavy, and I would expect those columns to maybe not match those underneath the 12-story tower, but to be fairly beefy columns to support that weight. The columns in several locations were also placed too far apart to prioritize parking below. So they moved columns further apart to allow larger drive aisles or more parking spaces, which is really unfortunate because if the building collapses, it doesn't matter because there's nowhere to park. So it's really unfortunate that that happened. Shear walls were also placed in 2 locations near elevator or stair shafts. And shear walls are long columns that look like a concrete wall, but those were also too small and they only provided support in one direction. Some beams originally planned for around the pool deck were left out of the final drawings and not constructed, and heavy planters around the pool deck didn't drain properly. And so those over time filled with water, which added weight to the slab and the columns below. And that is also a silly problem because you don't need to, sometimes we put planter drains inside of planters to help them drain properly. You don't even necessarily need to do that. You need to just drill holes in the side of them at the bottom so that the water can seep out. That's a very inexpensive and simple solution to allow the planter to drain properly. And even that wasn't done. There was also weakness where the main floor slab met the perimeter wall, and it also suffered water damage, requiring punching shear, which is when columns poke through the slab above, was calculated by engineers after the collapse and noted to always have been a risk. And so those mesh nets of rebar around the tops of the concrete, and the tie between the slab and the top of the column wasn't sufficient. And so it's possible that the column will punch through the slab, not necessarily, more like the slab falls through the concrete column. Due to these factors, which likely led to a number of cracks shortly after construction was completed, a lot of them hidden by decorative topping and pavers, the main floor slab sagged under its own weight by up to 40 millimeters or 1.5 inches in some places, which is significant enough, but maybe not a noticeable amount. Some sagging or sloping is allowable. It really depends on the structure and how it was built and what it's intended to do. And so to an untrained person, it's hard to tell just by eye, if 40 millimeters would have been an issue. Corruption during construction has been cited as a potential cause of the collapse. The architect and structural engineer had a number of issues related to cutting corners. The architect had his license suspended for gross incompetence after 2 billboards he designed blew over in a hurricane, and the engineer designed a parking garage that started to fail as soon as it was completed. So if they had a history of not following code and not following best practice, it's entirely possible that they knew that they weren't following building code. They knew that the contractor was cutting corners, and for whatever reason, they allowed it to happen. Even though there was some evidence that the engineer didn't complete proper inspections, the fact that it stood for 40 years before collapse through numerous hurricanes, and the excessive deterioration around the pool, and also noting that I'm completely speculating as a non-structural engineer, but all of these factors lead me to believe that water infiltration, which corroded the rebar around the pool, was the most likely culprit of the collapse, or at least the primary cause of the collapse. That seems to be the issue at play when the collapse occurred. The consensus among the structural engineering community, based on the publicly available evidence, was that a column or the slab itself under the pool deck failed, which caused the deck to collapse. This formed a crater under the middle of the tower and kind of in the courtyard around the pool, which then caved in. And we've seen similar examples on the other failures we've discussed. When any member of a structure fails, its load is transferred to adjacent members. If those adjacent members are strong enough, they can carry that load. But if they're not, they also fail, and it creates this domino effect leading to catastrophic failure. One resident on the 4th floor told her husband that a crater had appeared in the pool deck. Unfortunately, she did not survive the collapse. Another resident who survived later noted that the pool deck and street-level parking had collapsed into the parking garage just before the building collapsed. To add to all of these issues, the building had been sinking by about 2 millimeters per year since the 90s. Miami Beach was relatively stable. That's kind of the greater area that this condo building was in, but parts of it were still sinking, and this phenomenon is known as subsidence, and it's usually caused by the removal of groundwater, other minerals from the ground, which causes the pockets that water was sitting in between the earth materials to get smaller or collapse and the surface to drop. And this is what's happening in New Orleans. It was built on marshland, and as the groundwater is pumped out, it causes the surface level to drop. Although New Orleans is sinking at 6 to 8 millimeters per year, which is 3 to 4 times that of Miami. To add to all this, the Miami Herald did a really, really good investigative series on the collapse that ended up winning them the 2022 Pulitzer Prize. And we're going to include a link to that in the sources for this episode. I highly recommend checking it out. They have a lot of images, and even just the way it's broken down, it's not just a long article. It's not a wall of text. They kind of take you through step by step what was happening in the building and highlight the different sections and explain what was going on as they walk you through the collapse. It's really, really well done. It's really interesting.
A number of things have happened since the collapse of the building and since we initially covered this as a engineering news piece way back in the day. So the site was bought in May 2022 by a Dubai-based developer with proceeds from the $120 million sale going to the victims and their families. And in May 2022, a Florida bill was passed to create a statewide inspection program for condo buildings more than 3 stories tall, which this would obviously fall into. So in 2025, buildings will go through what is called a milestone inspection when they reach 30 years of age or 25 years if located within 3 miles of the coast. They will then be inspected every 10 years afterward. This seems like just a really good idea to me. and the records of each inspection must be posted online and shared with the tenants. In addition to all of this, condo boards will no longer be able to waive the requirement to keep a reserve fund large enough to maintain the structural integrity of the building.
Yeah, I didn't look into this too much because it doesn't necessarily have anything to do with the collapse itself, but it seems like there was some weird rules that allowed condo boards to keep a smaller reserve fund that didn't account for maintaining the structure of a building if it met certain requirements, or maybe even if they deemed that they didn't need to, which I think is really dangerous. Condo boards are generally not made up of structural engineers who have the ability to determine if the building structure needs repair. Not that they can't hire someone. I'm not saying that they couldn't figure it out, but giving them that autonomy to decide for themselves whether or not they need to maintain a reserve fund to keep up the structure of the building seems like a dangerous idea, especially buildings in this location that are so close to the coast, and buildings also that are more than 40 years old. This seems like a bad idea, and I'm not quite sure exactly what the rule used to be that allowed them to do that, but I did read that in a couple of different places that they were able to kind of just decide for themselves if they needed to keep a reserve fund for the structure, which just seems so weird.
So there you have it. A Champlain Tower South collapse on June 24th, 2021. A damaged pool deck with a repair plan that was too late led to the catastrophic failure of the 12-story condo building in the middle of the night.
For photos, sources, and an episode summary from this week's episode, head to failurology.ca. If you're enjoying what you're hearing, please rate, review, and subscribe to Failurology so more people can find us. If you want to chat with us, our Twitter handle is @Failurology. You can email us at thefailurologypodcast@gmail.com. You can connect with us on LinkedIn, or you can message us on our Patreon page. And check out the show notes for links to all of these. Thanks everyone for listening, and tune into the next episode where we'll talk about Lac Mégantic, a drastic train derailment in the middle of a tiny Quebec town that happened a decade ago. Bye, everyone. Talk soon.